In this video, we'll just talk about the example and run with that, and I'll show you some R code about what happens when we use a proxy variable as a proxy or as a substitute for a variable that we can't observe or we lack data on. So what we've seen so far, when we are regressing y on x1, x2, and x3, where x3 is just the proxy for x3 star, okay? This is called a plug-in solution to the omitted variables problem that we encounter. And it actually, we encounter this more frequently than not. So basically what we're doing is we're pretending that x3 star and x3 are pretty much the same in this plug-in solution, right? So we're trying to pretend that that's the case so that we can get some unbiased and consistent estimates for beta 1 and beta 2. Now, in our example, we said that wage is determined by education, experience, and ability, and then we've introduced this proxy variable. And notice this is not beta 3, this is alpha 3. And I've described what alpha 3 is and also what alpha naught is in the previous video. So we can estimate the ceteris paribus returns to education, even though we are only controlling for IQ. Okay. Now, you might think that, we're probably more interested in alpha 3 anyway, because we actually can interpret IQ. We can actually say what happens if IQ goes up by 1 point, what happens to the percentage return on wages, or what happens to the return on wages. So what I'm going to show you is, and this is just going over the same thing that I've described before, but I want to show you what happens when we run those regressions. So I'm going to do robust regressions, and if you don't remember what those are, then go back to the previous chapter where I describe how to do those in R. But basically, we're going to use the wage 2 data set from the Woolrich package here, and we're going to run 2 regressions. Okay, so regression 1 is going to be regressing log wage on education, experience, tenure, marital status, region, urbanicity, and some race variable. Here it's just whether you're black or non-black. I believe that's how the data is structured. And the only difference between regression 1 and 2 is that we're adding IQ in the second regression, right? So we're going to add IQ, and then we're going to just basically make these regressions that we ran robust by using CoFTest from the LM test package, and use Stargazer to print the results. So regression 1 is without IQ, and regression 2 is with IQ, okay? So notice right off the bat that the returns to education were 6.5% here and are 5.4% in the second regression. So we have removed, perhaps successfully removed, some of the bias in regression 1, which perhaps suffered from the omitted variables problem. Okay. So here we're also noticing that nothing's really happening to the coefficient on experience, not really much happening on tenure either, or on marital status, but the education, returns to education significantly changed here, okay? And you can look at some of the other variables. So here, let's look at IQ, for example. If we want to interpret what is going on with this coefficient, we're basically going to say that a 1 point increase in IQ is associated with a 0.4% increase in wages, ceteris paribus. Okay, and this is on average. Or if you don't like 0.4, then you can multiply these, by 10, and you can say a 10-point increase in IQ is associated with a 4% increase in wages, right? So maybe a 1-point jump in IQ is not going to do much, but a 10-point jump is something maybe, right? So maybe you want to look at something more substantial here and make those connections. Okay, so that's the idea here. And also remember that if you think the return to education might change with ability, then it makes perfect sense to interact the proxy, which is IQ, with education, okay? And then compute, what are the partial effects.